Silhouette cutting machines are blade-driven precision instruments that can cut a variety of material types, ranging from very thin materials such as vinyl to thicker materials such as craft foam. The ability to cut select materials depends on a few factors. The first factor is the thickness of the material. Depending on your Silhouette cutting machine model and blade, materials up to 3 millimeters in thickness can be successfully cut. This limitation is based on maximum height of the blade and the maximum clearance of the machine. The second factor is the density of the material. For example, you can have two sheets of material side by side where they're both 1 millimeter in thickness, but one sheet is made out of foam and the other is a sheet of metal. Obviously, blade-driven devices cannot cut through metal and other denser material types just because the material thickness is within the target range. Though density is difficult to measure in terms of ability to cut, as a general rule, if you cannot cut the target material with a pair of scissors or manually with a craft knife, then it will not be able to be cut by a blade-driven cutting machine. As you go to cut new materials, start by looking for an existing setting in the software that matches your material type. If there is an existing setting that matches your material type, select it. If this is the first time you've attempted to use this material, be sure to perform a test cut before sending your entire job. The test cut feature is found in the Send Us section at the bottom of the panel. The test cut will create a small triangle inside a box wherever your blade is currently positioned. If you haven't used the arrows to reposition your blade, it will be performed in the upper left corner where the blade position is set by default. If the test cut works well, your job should likewise cut properly and you can proceed to send the job. If adjustments are necessary, or if you're starting from scratch with a unique material type, the following are guidelines and settings you'll need to consider. The blade number setting indicates the amount of blade exposed from the blade tip in 0.1 millimeter increments. The higher the number, the more the blade will be exposed, and therefore the deeper the cut will be. The blade number setting should match the actual thickness of your material. For example, if you're working with a sheet of cardstock that is 0.3 millimeters in thickness, you'll want to set your blade to a setting of 3. If your test cut is too deep, you can reduce the blade number and decrease the amount of blade tip being exposed. When considering the blade number setting, always make sure that the correct blade or tool is selected in the software. If using an auto blade, the setting will automatically adjust to the number displayed in the software, so all you'll need to do is tell the software what setting to use. All other blade types need to be adjusted manually to the recommended or selected level prior to loading them into the machine. For these manually adjusted blades, the software setting displayed on screen is simply a prompt to remind you what setting to use for the material in question. The force setting controls how hard the blade is pressing down. If your material is tearing and cutting too deeply, you will want to reduce the force. If the blade is not cutting all the way through the material or just scoring the surface, you can increase the force to achieve a better result. As you work to define your material settings, remember that the key to successful cutting results is to find the lowest possible combination of blade and force settings where the Silhouette is still able to cut your material successfully. Setting the blade or force setting too high can still achieve results that look good, but which can also wear down your blade more quickly because it is either overexposed or pressing down harder than needed. The speed setting controls how fast the cut is being performed. In other words, this is the speed of the left-right movement of the blade carriage as well as the in-out movement of the roller bar feeding the mat or material in and out of the machine. Though some material types need to be cut more slowly in order to cut properly and cleanly, faster levels are available to make the overall cutting process go faster if you're using compatible material types that can be cut more quickly. Generally, thicker and denser materials require slower cutting speeds, whereas select lighter materials such as thin film-type materials, including vinyl and heat transfer, or thin paper-based materials such as sticker sheets can be cut more quickly. If creating settings from scratch for a new, undefined material type, always start with a slower speed setting and work your way up according to the results. You may wish to lower the speed level if you're finding that certain parts of the design are tearing, most often in the corners of the design, or if the material is being lifted from the backing during the cutting process. These three settings, blade setting, speed, and force, are the basics for all material settings. There are also additional cut settings available that may be necessary for certain material types as follows. The passes setting tells the machine how many times it should cut the design. This setting is defaulted for a setting of 1 for most materials. For some thicker materials, such as chipboard, it may be increased as additional cutting passes are required to achieve clean cutting results. If you're cutting a thicker or denser material and it is not cutting through after increasing other settings, you may increase the number of passes in order to provide a cleaner or more complete cut. By default, the line segment overcut setting is off. While off, the blade will cut each shape normally without lifting. During the cutting process, the blade tip normally rotates to accommodate corners and curves. However, if you are using a material that requires weeding, such as vinyl or heat transfer, or the corners of your design are slightly torn or not cutting through with regular cutting attempts, you may wish to turn on the line segment overcut setting. When this setting is on, the blade will begin cutting slightly before the line begins and then lift between each line and finally end the line slightly beyond the actual original line. This overcut is very small and usually unnoticeable. The intention of this overcut function is to create a clean cut corner for each point where two lines meet.